now a part of my brain's going to be thinking of jokes, which means keep your eye on me for mistakes. Right, we're doing this weird thing called trig substitution. It's used as a very niche market. Whenever you have to integrate something with square roots that look at like one of these three typically, then you're going to use this technique called trig substitution. I like to call them X subs. So if you ever have an integral, it'll have other stuff, but does it have 9 minus x squared, 16 minus x squared, 25 minus x squared, or at least something that can be made to look like this? If that is the case, you're going to use trig substitution, and your trig substitution is going to be a sine theta. So if that's 9, right, if that a squared was just 9, if that was 9 take away x squared, you'd use 3 sine theta. If it was 16 take away x squared, you'd use 4 sine theta. On the other hand, if you have the two things added, you're going to use a tan theta. And if you take this one and switch places and have an x squared first, take away a number, no, I don't know, x squared take away 16, for instance, you'd have 4 secant thetas. So these are the three guys that you either memorize or you write down. Now I've got a little list of the 3 possible things, and we're going to look at as many questions practice as I can, but they take forever in a day, as you've already known. So let's start off with question 1. It looks like this guy. Now it's x squared plus 64, but that's the same thing as 64 plus x squared. Okay, so that's what this 1 is doing. It's telling us that you're going to use a tan theta. So let's see what that would look like. X squared plus 64, oops, you get 8 tan theta. Are you happy about how I can look at this little chart over here and decide which x sub to use and what number goes next to the sine, tan, or secant? In this case, 64 gets me an 8. We're good with that choice. Right, okay. From this bit on, it's pretty standard. You differentiate with respect to theta, and a tan gets you a secant squared. And then you do the crossover. And normally, that's it. So it's like a U sub, isn't it? You do the same kind of things, but it's an x sub. Now, what this is telling me is that this dx is going to get replaced by these theta stuff. So I'm going to go in and take each piece and switch it. X cubed is going to be this guy cubed. So that's a tan theta cubed. On the bottom, I'm going to have a big square root. This guy squared. So that's a tan theta squared plus 64. And the dx is going to be another 8 secant squared theta d theta. So typically what you should be left with here is a whole load of ugly trig with thetas in it everywhere, right? So the next few lines, my goal is to make that as pretty as possible, because if you make it pretty, it's probably going to be integratable in a reasonably easy way, fingers crossed. So there's quite a lot of things I need to do. If you cube this, I'm just going to call it 8 cubed. I know that's a number, it's a huge number, but I'm just going to call it 8 cubed. And this guy is going to be 8 secant squared. And on the bottom, I've got my big ugly square root, but it's now going to be 64 tan squared plus 64. So far, so good. I'm taking this as slow as I can. This and this, I now have 8 to the 4, which is even uglier than the one that was a minute ago. I can live with ugly. Now, what will guarantee to happen, and if it doesn't, you're screwed up. See this ugly square root? He is going to become something nice. So let me do it at the side. 64 tan squared theta plus 64. If you pull out the 64 as a common factor, which you will be always able to do in this, you get that. Does anybody know what tan squared theta plus 1 turns into? He was in my little list and he's kind of there or thereabouts. Last chance?
Squared.
There you go. In a way, wouldn't it have to be something squared if this is going to turn out nice? Now, what do you get? You get 8 secant thetas. So back to my question. You get 8 secant thetas d theta. And now I'll do some cancelling. Not much, but that will cancel with that and leave me with 8 cubed. This will cancel with one of them and leave me with a secant. So I'm now left with 8 cubed, tan cubed, single secant theta, d theta. Now, in most questions, you would be ready to start integrating and calling it good, but that's not the way these guys work. It's like Russian dolls. Inside each doll, there's another doll that you have to get inside, and sometimes inside that one, there can be even another doll. So you just keep going. Forget where that came from. If I asked you to integrate this, right, which I'm going to do over here because it needs more room. If I ask you to integrate this, can I just pull out the 8 cubed outside? That way I can forget about it. And focus on this fella. That's the previous section, isn't it? If you want to integrate this, don't you have to do a U sub? A good old-fashioned U sub, right? Just a normal U sub. And when you have a U sub, don't you have a decision to make? Sine or cosine, or secant or tan, right? It depends on the combination. Would you agree this is a secant or a tan? And one of them works and the other doesn't. If you pick the wrong one, then you throw a bit of the paste and you pick up the other one. Which one do you believe is the working one, the one that does work?
Tan's gonna work.
You think so? What do you get if you differentiate a tan? Let's think it through.
Secant squared.
Is there a secant squared in here you can work with? No. So
you want to? Because you want to make it secant so you can. Okay. Disregard.
Okay. But that's what you do. You say to yourself, "I'll try tan," and then think it through. Nah, forget it. I'll try secant. The secant's going to get rid of a secant and a tan. Like it. So you can sometimes do it in your head. Not the whole details, but you know, the gist of what you need to know. If you differentiate a secant, you get secant tan. If you do the crossover, you get a secant tan d theta. And when you isolate the whole thing, you get this guy, you get this guy, a du, and you isolate the d theta. So I've got 8 cubed. Typically, when you do tangents, you write everybody down. You don't start turning things into U quite right away. You give them a few seconds to see if anything interesting happens. Okay, we're at that stage, right? Tan cube secant, 1 over secant tan du. There's a little bit of cancelling going on. One of these, one of these, one of these, one of these, and we are now left with that. I'm going to take out the mute button because I'm getting some feedback, which is a little bit distracting for me. So you just hit the space bar when you want to talk. Right, so we're up this point here. Don't we have to figure out a way of writing tan squared using secant? So that's where we're off to next. What is tan squared in terms of secant? I'm looking for my piece of paper. That's probably what you should be doing too. Right, unless I threw it away, which is also possible. Looks like
Secant
it.
squared minus 1.
Okay, thank you. Which means this becomes u squared minus 1, which then becomes 1/3 u cubed take away u plus c. Okay, that 8 cube's been 8 cubed too long. 512, okay. So it's 512 over 3 u cubed, take away 512u plus c. How many lines is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We're on line 12 and we're about halfway through. Okay, what do I now do? I have the answer in terms of u, but what should I do next?
Put secant theta back in.
Agreed? Now, if the question had been find an integral with secants in it, I'd be finished. But it's not. The original integral had x's in it, so don't I now have to turn this into stuff with x's? But it's not your just, you know, the usual u sub substitution thing. It's much messier than that. So this is pretty much a guaranteed phase. You return to that piece of information. Now, I'm going to write this guy down so I can move this piece of paper out of the way. Right, darn it. I'm not doing anything new, I'm just rewriting it a second time because the other guy was just too close. There we go, right. Now what you do is you take this fella, you take this fella, right, your original x sub. Now what you need to do, what you need to do with this x sub is to rewrite it so that in this case tan theta is a fraction. That is going to create a right angle triangle. This happened before. And this angle in here is going to be called theta. And this side is the opposite. And this side is the adjacent. And this side is hypotenuse. And we use a guy that we got from trig called SOHCAHTOA. Right? Now, according to SOHCAHTOA, the tangent is the opposite over the adjacent. So I put opposite here, adjacent here. And that allows me to say the opposite is the top guy, x, and the adjacent is the bottom guy, 8. And then can't I use Pythagoras to get this third side? And it ends up being the square root of, make sure I get it right way around, x squared plus 8 squared. And that is good news, because shouldn't that guy be the guy right at the beginning? If this guy ends up being x squared take away 64, 64 take away x squared, you know, stuff that looks different, somewhere earlier you screwed up. Right? That is guaranteed, the way it works, to be that guy. Well, now that I've got this triangle set up, what's its job? Its job is to turn these things here in thetas into x's. So if I asked you how to find the secant of an angle, there are a couple of ways to do this, but one of the most obvious ways for me is, isn't it 1 over a cosine? Do you agree a secant is 1 over a cosine? Now, according to SOHCAHTOA, what is a cosine equal to? Well, isn't a cosine adjacent over hypotenuse? And adjacent is 8 over ugly square root. And how do you get this ugly fraction, which is 1 over this? Basically, reciprocal. So secant of theta is turn this upside down. And now I can plug it in here and here, and we're pretty much gone. So what's it going to be? 512 thirds secant cubed. Take away 512 secants. Okay, not too much, but I can do a bit. 8 cubed, what's 8 cubed when it's at home? I think I know what that's going to be, but I want to check. It is 512. So I'm going to get 512 cancel with that 500 because 8 cubed is 512. And I'm going to have 1/3 that guy. 8 into that guy isn't so nice, but at least it works a little bit. And I'm left with 64. That took 20 minutes. That is how long these darn questions are going to take. I've actually went in and knocked off, I think, 3 questions. So you've got less to do, but that's still going to take you a heck of a long time. So don't wait until 10 o'clock on Sunday and think you're going to get these done. So before I move on from this question, let's talk about the main phases. Phase 1, your original integral with the x's in it, you had to choose one of 3 possible x subs. In this case, 8 tan theta. That allowed this fella to be turned into this guy. That's kind of phase 1 finished. Phase 2, you took this guy and you solved it by whatever means you need. In this case, a u sub. If you're really, really lucky, won't this guy just be sine theta and you'll say thank you? If you're really lucky. And if you're really unlucky, won't it be a guy that looks like this and you have to do more work? So phase 2 is you integrate this fella. And in this case, it was a u sub. And I got this answer and then converted it back. So that's phase 2, where you have the integral with thetas in it. So what's the final phase? Well, this is the final phase. This is the answer with thetas. What we then do is we use the original x sub, turn it into a fraction equal to, in this case, tangent. That allowed me to build this triangle. When you've built this triangle, you can then turn whatever these things are into x's. In this case, it was a secant, but maybe next time it's 10 sine theta, cosine theta, right? It's got stuff like that in it. Whatever it is, you can get it. Would you agree you can get sine theta, tan theta, secant theta, anything you like out of this? And isn't secant cubed just the secant and cube it? And then tidy it up and you got it done. So that one that I've just done is going to represent the 8 tan theta, right? The ones where you use tangents. So for my next question, I'm going to find a different one that doesn't use tangents. Let's find one that doesn't use tangents. Let's find one. Oh. No. Let's see what that one looks like. That one will do. Okay, so this one is my question 4. And we are going to look at the integral of x squared take away 16. And underneath it is an x cubed and a dx. Now, can you see, because it's an x cubed take away a number, it's a secant story. And the x sub that I'm going to use is going to be a secant theta, 4 secant thetas. Okay, so we are going to go through this thing pretty much the same way as we did the last one. So phase one is integrate this and get an answer in terms of the integral of thetas. So if you differentiate 4 secant theta, you get 4 secant tans. You do a crossover, you get 4 secant tans d theta, and if you isolate, you get 1 over 4 secant tans dx is d theta. Are we comfortable with the x sub? And I just did something there that I didn't need to do because my brain wasn't thinking. What did I do there that I didn't need to do?
You didn't need to divide both sides by the 4 secant.
Yeah. You know, when you do x subs, you only have 3 lines. Right? You don't need to do the fourth. In fact, it's a good idea not to do the fourth one. So let's see what we get. We get a square root of this guy squared. So that's 4 secant theta squared, take away 16, over 4 secant thetas cubed. And the dx is 4 secant thetas tan thetas d theta. So I get 16 secant squared thetas take away 16, 4 secant tans, and I'll just call it 4 cubed, secant cubed. Okay, let's see if I can save a line. What will 16 secant squared take away 16 get me? You could guess what it was.
Or tan theta.
Yeah, it's going to get me 16 tan squares, which is just like Brendan said, 4 tan theta. That 4 gives you a 4 squared. That tan gives you a tan squared, and you get a secant. So I've combined a couple of guys together in this line as well. Right, time for cancelling. 4 squared and 4 cubed leaves a 4 on the bottom. Secant cubed, and that guy leaves me a secant squared. We are looking at the integral of tan squared theta over secant squared theta d theta. Now, we have done sines and cosines multiplied. We've done secants and tans multiplied. What we haven't looked at so much are tans and secants, or sines and cosines of them, are in fractional form. Right? Good job. So, any suggestions for what I might do to solve this one? Because each question is unique. You figure out what to do based on what's in front of you. Any ideas about how to rewrite tan squared and secant squared that might work?
Could you rewrite them as sine squared over cosine squared over 1 over cosine squared?
Yes, you could. And that is actually what you should do. Now the hard part. Do you know that this and this cancel? You can't you take the top and multiply it by the reciprocal? And they cancel as sine squared. So that might be what you started with, but this is the guy we're going to integrate. Now, if you don't believe that, take this guy and divide him by that guy. Take this guy and multiply him by the reciprocal. Do you see the cos squares cancel? Okay, back to this fella. Is there some other way of writing sine squared on its own? We did this on Monday. I'll give you a clue, there's a half in it.
One half 1 minus cosine of 2 theta.
Which means we now have 1/2 take away 1/2 cosine 2 theta. And all of that was just so that we could integrate this thing. So let me take it up here. We have 1/2 take away 1/2 cosine of 2 theta. That gets me 1/2 theta. The linear shortcut method will work with this. If you integrate a cosine, you get a sine. But because it's 2 theta, you get an extra 1/2, so that's where that came from. That's phase 2 finished. We've got the answer to the integral. It's in terms of theta. So I'm going to return back to this fella. And I'm going to convert it into a fraction. And then I'm going to do this fella. If secant theta is x over 4, won't cosine theta be 4 over x? Does that make sense? Reciprocals of each other. And this is the guy I need because I need to have an adjacent hypotenuse thing, right? And SOHCAHTOA really works with sine, cosines, and tans. So here's my angle, theta. I'm going to call this opposite. I'm going to call this adjacent. I'm going to call this hypotenuse. And what do we know? Adjacent is 4, hypotenuse is x. So shouldn't the opposite be this guy squared, take away that guy squared, inside a square root? And is that good news? See it? Matches. Right. What we got here? Ugh. I need to use this triangle to convert these into x's. This will be fun. If the cosine of theta is 4 over x, then won't theta be the inverse cosine of 4 over x? Are you happy about how I found theta? Right, I need to know theta. I need to find out what the sine of 2 theta is using this triangle. And this is going to involve us remembering a trig expression, identity, for the sine of 2 theta. And the sine of 2 theta is 2 sine theta cosine theta. Do you remember that one? The sine of 2 theta can be written like that, which means that it can be written as 2 times the sine, which is this over this, times the cosine, which is this over this. And so I get 8, the square root of x squared take away 16 over x squared. Okay, 1/2 theta is 1/2 of this. Take away 1/4 of this. 1/4 of this gets you -2. I'm getting better. 15 minutes. There is tons of little things that you need to be able to do, conversions you need to know, mixing things up to get them into a form that works for each question. And that one is number 4. So I'm going to put that one down there. Are we good? Okay, so there's only one left, right? We want to look at one that has this format, right? So let's see if we can find one that has this format. I'm looking for a number take away x squared, a number take away x squared. Come on, a number take away x squared. Shooting space. I will give you 2 versions of this. This is going to be the first one. It's going to be x squared over the square root of 9 take away x squared dx. Now, when you get number take away x squared, as you have here, you're going to use 3 sine theta. Are you happy about why it's 3 sine theta based on the shape of the square root? If you differentiate with respect to theta, you get 3 cosine thetas. If you do the crossover, and this time I'll remember to stop, you get that. So my integral becomes x squared becomes 3 sine theta squared. 9 take away 3 sine theta squared. The dx is 3 cosine thetas d theta. I have 9 sine squared theta. Oh, times 3. Okay, so I now have 27 sine squared cosine thetas. Okay, let's try to do this in one go. Won't that be 9 take away 9 sine squareds? Right, 9 take away 9 sine squareds. What does 9 take away 9 sine squareds become? So in a little list, 9, take out the 9, what does 1 make? 1 minus sine squared get you?
Cosine squared.
Cosine squared. So 9 take away 9 gets you 9 cosine squareds. The square root of 9 cosine squares is 9 cosine thetas. So I did a lot in one go there, but if you've got your little identities, you can fill in the missing lines and you get that. Now that mess there says 27. So when I cancel them, I've got 9 and they cancel out and I have sine squared theta d theta. So that's kind of phase 1 finished, isn't it? We now have an integral with nothing but thetas. Oh, wait a minute, I'm getting deja vu here. Is it not? This guy. So can I tell you that this guy turns into that guy, turns into that guy, which when you integrate it becomes, well, I've got a 9 here. So it's 9 lots of a half, take away the cosine of 2 theta. So that's going to give me 9 over 2, take away 9 over 2 cosine of 2 thetas. And that's phase 2 finished, because that one integrated really nicely. So now phase 3, return back to the x's. So x over 3. And that's opposite, and that's hypotenuse. So this guy ended up being sine squared, which eventually integrates out to be this fella. We're now going to figure out how to turn this fella somebody didn't notice my mistake. Wasn't there 2 more lines to this till you got to here? So it's this guy here times 9. So you get 9 to thetas. Take away 9/4 the sine of 2 theta. I looked there and didn't realize that the final answer was here. So that's my mistake. So that's the guy that we're going to fix. Build my triangle. Put a theta here. Do an opposite. Do an adjacent. And finally do hypotenuse. The opposite is x. This is 3. According to Pythagoras then, this is that guy squared, take away that guy inside the square root. Good news, matches. Opposite x, hypotenuse 3, third side, big guy squared, take away little guy squared. 9, take away x squared. So I need to find theta again. So let's see what I have. Sine of theta is x over 3. So theta is, in this case, going to be the inverse sine of x over 3. I need to find the sine of 2 theta in terms of x. So that's going to be this fella. It's going to be 2 lots of the sine, opposite over hypotenuse, which is x over 3, times a cosine, which is adjacent over hypotenuse. And that ends up being 2/9 of this stuff. So the answer was 9/2 theta, take away 9/4 the sine of 2 theta. 9/2 of this fella. Take away 9/4 of this fella. Actually, I got a little bit to do, not much. But I have this fella. That cancels, that's cancelled, that partially cancels, and I'm left with that. What did I take? Nah, took 15 minutes, that one. So we've seen a sine, we've seen a secant, and we've seen a tan, right? We've seen all 3 flavors, right? And what they look like. So what's left for the last few minutes? Question 6. Oh, it's worse than that. Why you can't have pens that just rub out when you make a mistake? Probably there is pens that do that. There we go. That's the question. The big problem, it doesn't look like this. Do you see there's an ugly 25 there that we don't want? And this is the only question where that happens. So I'll show you how you deal with it. The second question is, do you see how there's limits of integration here? from 0 to 0.6. Well, that's not such a big deal. Can you imagine that this is my answer? Don't you just put x is 0.6 and then x is 0 and then you evaluate it? So that's not as bad as it seems. This is how I'm going to tackle the awkwardness of not having an x squared. I am going to make it x squared. And I'm going to do that by pulling out a common factor of 25. Wait a minute, that doesn't have a common factor of 25. That's true, but I can still fix that. Then I'm going to pull out that 25 inside the square root and just have it here. Now, our question is ready to go. Is this a sine, a tan, or a secant story? Is it a sine, is it a tan, or is it a secant?
Sine.
Great. And it's going to have a number or fraction here. In the questions we've got, it's always been 3 or 5 or 2 or something. What's it going to be in this case?
Three over 5.
Yeah. That's the intro over with. Treat this question exactly the same as the ones that we've done previous and you will be fine. So that guy is question 6, goes there. Now, for the few moments left, I'm going to go through each question and tell you which one of these 3 stories it is. Right, so question 2 is going to be a secant. Question 3 is going to be a tan. Question 4 is going to be a secant. Oh, I've got that one already.